Solid principles. In software design, the solid principles are a set of guidelines that help developers create more maintainable, scalable, and understandable code. SOLID is an acronym for 5 principles, each with its own role in helping keep code from becoming a tangled mess. Let's break down each principle. Single responsibility principle. The single responsibility principle states that every class or module should have only one reason to change. In other words, each class should focus on a single job or responsibility. Example: SpongeBob SquarePants. Think of SpongeBob at the Krusty Krab. His main responsibility is to make Krabby Patties. Imagine if SpongeBob were also responsible for handling finances, cleaning, and customer service. It would lead to chaos. Similarly, each class in code should have one specific job: to keep things organized. 2. Open-closed principle. The open-closed principle states that software entities like classes or modules should be open for extension but closed for modification. This means you can add new functionality without changing existing code. Example: Pokémon universe. In Pokémon, each generation brings in new Pokémon, but the core game mechanics, like catching and battling, stay the same. Developers can expand the game by adding new creatures without changing the core gameplay. This is the essence of OCP. We can extend functionality without rewriting core components. 3. Liskov Substitution Principle. The Liskov Substitution Principle ensures that objects of a derived class should be able to replace objects of their base class without affecting the program's correctness. Example: Super Mario. In Super Mario, both Mario and Luigi can run, jump, and navigate levels. You can swap Mario for Luigi, and the game won't break as they follow the same hero template. Imagine trying to swap Mario with Yoshi, though. Yoshi's abilities would completely change the gameplay. Liskov Substitution Principle ensures subclasses can substitute the main class without disrupting functionality. 4th Interface Segregation Principle. The Interface Segregation Principle states that classes shouldn't be forced to implement interfaces they don't use. Instead, create smaller, specific interfaces tailored to a class's needs. Example: the Avengers. In the Avengers, each hero has different abilities. Iron Man can fly, while Hulk focuses on smashing. It wouldn't make sense for Hulk to have a fly ability. It's not his style. Similarly, each class in software should only implement the abilities it needs. 5. Dependency Inversion Principle. The Dependency Inversion Principle states that high-level modules should not depend on low-level modules. Instead, both should depend on abstractions. This allows components to work independently and makes systems more flexible. Example: Batman's utility belt holds gadgets like the Batarang, grappling hook, and smoke bombs. Instead of relying on the specifics of each tool, Batman just needs a standard way to use them all. This lets him swap gadgets in and out without changing how he uses the belt. Similarly, dependency inversion means high-level code relies on shared interfaces, not on specific details, making systems flexible. The SOLID principles help developers create more organized, adaptable, and resilient code. By following these principles, we build systems that are easy to maintain and extend. Just as cartoons and games follow their own rules for keeping things orderly and fun, these principles guide us toward better code design.